Alright, welcome to today's Moodle video. We're going to be focusing on factoring and all the different aspects of it that we can find with polynomials. So once again, this is our key. The first thing when we're trying to factor a polynomial, the first thing we have to check for is a greatest common factor. A lot of you may know greatest common factor or remember the initials GCF. Now when we're looking for a GCF, there's a couple things we have to check for. We have to check for a GCF both of the coefficients and also for the variables. So for example, if we have something like 3x squared plus 6x, we're going to start by finding the greatest common factor of the coefficients. In this case it's 3, so we can pull 3 out, and the greatest common factor amongst the variables, which is x, 3x. What we're left with then is x plus 2. This is kind of like using the distributive factor, but we're going to go in reverse. Rather than putting 3x into x, we're going to take it out, see what we're left with. There are two primary types of factoring methods which we're going to cover today. The first is factoring by grouping, and factoring using guess and check. You're going to have to decide which method you'd like the best. We'll go over both types of methods, but once again, you're going to have to decide which one you like the most. Starting with some basic problems just by pulling out the greatest common factor. For me, I think the easiest way is to start with the coefficients. -4, 6, -12. My leading coefficient is a negative. I personally don't like having a leading coefficient of a negative number, so I'm going to pull out that negative. And then we're going to have to find the greatest common factor between 2, 4, and 12. There's a lot of different methods we do this. Hopefully at this point they're kind of apparent. If it's not, you can always use the prime factorization trees and go from there. In this case, the greatest common factor is 2. If we just look at the coefficients, we're trying to realize, hey, what number can I multiply -2 by to get up to -4? In that case, it's 2. What number can I multiply -2 by to get to 6? Well, that's -3. Same thing to get to 12. What we're going to be left with is a -6. At this point, we can go and kind of check the exponent or the variables: x cubed, x squared, and x. The largest variable we can pull out is x with a degree of 1. We're kind of seeing what's left. Well, when you pull x from x cubed, we're left with x squared. X from x squared, we're left with x. And we don't need an x there, because it's already accounted for when you pulled out a GCF. So we're left with 2x squared minus 3x minus 6. The resulting polynomial we're left with, 2x squared minus 3x minus 12, is a prime polynomial, so there's no other factor we can do. So in this case, we're done. The next one, we're looking for the GCF. It becomes a little bit more complicated. What we have to notice is that terms that can be written as binomials can actually be a factor. In this case, x plus 2 is a factor of both 3x times x plus 2 and -4 times x plus 2. When we pull that x plus 2 out, because it's common amongst both of those terms, what we're left with is quantity 3x and -4. In that case, the factoring is actually pretty simple, but it's just hard to recognize that sometimes our factors can be binomial expressions. So 3 times quantity x plus 2 minus 4 times quantity of x plus 2 results in x plus 2 times 3x minus 4.